Okay, this is a calculator-specific problem, and based on the derivatives that we know at this point, I have to use a calculator to do this. Graphing features of a calculator. So, there's a couple ways to work with and derive on your calculator, but I prefer to always make y1 my function, because then I can kind of reuse and derive, and it just makes life easier sometimes. So I'm going to make y1 this guy right here. So y1 is going to become e to the 3x minus 6x squared plus 1. And what I'm going to do in y2, and I'm actually going to turn this off when I go to my graph, because I don't want that guy to get in the way. And it's okay, I can use y1 in my y2, which you'll see I'm going to do in my derived in a moment, and still have y1 be off. So I'm going to make y2 equal to n derive of y1, comma, remember, it's function, and I'm not even going to write. In my n derive, it's three things separated by commas. First thing is the function, which in this case is y1. If you wanted to type in this as your function in your n derive, when you say n derive right here, you could totally do that. But I just prefer to do it this way. So it's function, comma, variable, which in this case is x, and then we want to do value. So if I just wanted to find the derivative of this thing at x equal to 7, I would type in 7. And I probably wouldn't type it into my y equals screen, because that would be, it would just be constant. But I don't want it at 7. I want it at any variable of x, or any value of x. So what when I hit graph, which I'm going to do next, I hit graph, it's going to graph the derivative of y1. And as long as I make sure that this is turned off, then this will be the only thing that shows up on the graph. So what I wind up getting is a graph of f prime of x, and I believe it looks, if I do a zoom 6, I believe it looks something like this. And we can't really tell where the min is. I do a second calc min. If you remember, my mins and maxes of my derivative, f prime, tell me where a point of inflection is. This is where the derivative is increasing, which would mean derivative increasing. And then as soon as I hit this point, the derivative starts to decrease, so it starts to decrease. Notice when I go from increasing derivative to decreasing derivative, I get a point of inflection, change in concavity. So anyway, I calculate the minimum point of this thing on my calculator. I do a second calc min, do left bound, right bound, guess, and I get x equal to 0.096. And that is my answer.